So, good afternoon, classmates. Good afternoon, Professor Charlton.
Afternoon.
The first topic na pag-usapan po natin is pressure. So, by definition, pressure is the force applied perpendicular to the surface of an object per unit area over which the force is distributed. So, the formula is P is equals to F over A. And in this diagram, assuming that it's a cylinder being pushed and experiencing force and it will hit the plate here, then this plate is experiencing pressure po. Okay?
Okay.
Then the units po for the units of the pressure is the SI unit is Pascal or the Newton per square meter. But other common units po is itong bar, PSI, ATM, inch of mercury, millimeter of mercury, and toricel. Then to appreciate po yung the definition kanina ng pressure, may simple problem po dito. Dito po siya. A force of 40 Newton acts over an area of 5 square meter. Calculate the pressure. So the formula is P equals to F over A. Then substitute lang po yung the given values. 40 Newton over 5 square meter is equals to 8 Newton per square meter or simply 8 Pascal. So next, the pressure unit conversion. So in the on the first column po, the units. The second is the abbreviation, and the third one is the equivalent. So the atmosphere or ATM is definitely 1 ATM since it will equivalent po siya ng 1 ATM nga po. Then next is millimeter of mercury or mmHg. 1 ATM is equals to 760 millimeter of mercury. Next is torricelli or tor. 1 ATM is equivalent to 760 torricelli. So next, inches of mercury. The abbreviation is in Hg. Then 1 ATM is equivalent to 29.9 inch of mercury. Next, pound per square inch or PSI. The abbreviation is PSI nga po. Then reminder, yung pound po na sinasabi dito is not pound mass. It is pound force per yun po. Then 1 ATM is equivalent to 14.7 pound force per square inch or PSI. Then next is Pascal. The abbreviation is PA. 1 ATM is equivalent to 101,325 Pascal. Then to add lang din po si unit bar. Abbreviation is bar then. Then ang 1 ATM na bar po is equivalent po sa 1.01325 bar. Next. So types of pressure. Okay, for the first type is the absolute pressure. By definition, it is a pressure that is relative to the zero pressure in the empty, air-free space of the universe. This reference pressure is the ideal or absolute vacuum. It is denoted with the subscript ABS or ADS. Back lang. Yan. So, sinasabi lang naman dito sa sa definition na pag sinabing absolute pressure, ibig sabihin, nag-refer siya dito sa kumbaga yung reading, nag-start dito sa tinatawag na absolute zero. Sa zero pressure. Tapos up to in arbitrary pressure ng magiging given. Next. Second is the tinatawag natin na atmospheric pressure, also known as the barometric pressure. It is the pressure within the atmosphere of the Earth. The standard atmospheric pressure is defined as 101,325 Pascal absolute at sea level. Kailangan pong tandaan na at sea level yung tinutukoy doon. Then si atmospheric pressure is rin siya, absolute value siya kasi si atmosphere nag-start yung reading niya from the absolute zero. Then makarating dito sa gitna which is the the atmospheric pressure line at sea level. Yun. Tapos to add lang din, sabi dito, atmospheric pressure decrease with height and liquid pressure increase with depth. So, paano nga bang yun, sabing ganon? Kasi, um, i, ang air ay mas dense. Mas dense kapag nasa mas malapit sa sea level kesa sa high altitude. So, yung density na yun, siya, pwede siyang i-associate sa weight. And ano nga ba si weight? Si weight is force. So, sabi nga kanina dun sa definition nung pressure, the pressure is force over area. So, since less dense ang weight or pressure dun sa high altitude, so yung ma-experience niya na pressure doon is bababa rin kasi directly proportional siya doon. Assuming na yung area is constant. So, how about naman dito sa sinabi na liquid pressure increase with depth? Okay. So, ito, imagine you are a diver. Okay. Then you will submerge to the water. Then, mentras na lumalalim ka, mas nararamdaman mo yung bigat ng tubig. Then, babalik na naman tayo dun sa definition ng pressure na force over area. So, bumibigat, tumataas ngayon yung force na na-experience ng area, then tataas ngayon yung pressure. Next. Ito naman is the instrument. A barometer is a scientific instrument used to measure atmospheric pressure, also called the barometric pressure. So, one type of it is Mercury Barometer. Right? Yung lang po nakuha ko dito, sir. Yung Mercury Barometer lang po. Ay, okay. 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 So, Mercury Barometer. A Mercury Barometer, also called as a manometer, is a glass tube filled with mercury, that is closed on one end and open on the other. The open end of the tube is temporarily sealed, so the mercury doesn't flow out. Then it is submerged below the surface of an open to atmosphere mercury reservoir. Okay, the seal on the open end is removed, which causes a portion of the mercury to flow out of the tube, forming a near vacuum at the closed end. Yung tinutukoy po doon, yung closed end na to. Sa millimeter of mercury po, andito po siya kanina. Okay po, 760 po. Millimeter of mercury po. Apa. Inch po. Okay. Next po is yung aneroid barometer. Ito po, wala po na pero pwede po. Wala, pero pwede mag-search po. Aneroid. Opo. Ay, sige po. Ilipat ko lang po yung apa. Ayun po. Ito po, aneroid. Ay, kasi. Ano po kasi siya, para siyang rin, sa definition po kasi, si aneroid, sa definition po kasi si aneroid is barometric, instrument, barometer is made without the use lang po ng mercury or any other fluid. It consists po ng a small flexible metal chamber called an aneroid capsule. Yun po, doon po bali siya nakuha yung pangalan niya, sa aneroid capsule po. Then, made of po yun, beryllium or copper alloy. Then, the chamber is sealed with most of the air pumped out of it. The difference in pressure between the inside chamber, a near vacuum po yun, yung loob nun. And the outside cause it to expand or contract. Tas dun, yun nga po yun yung same principle na rin po siya nung sa ano po, nung sa barometer na mercury. So, apa. Next, next po is ito po, digital microelectromechanical sensor. Ito rin po wala pong nakuha kanina. Pero try ko po. Digital electrical. Uh, mechanical. Sensor. Mm-hmm. Opo, yun nga po. Digital. Ito. Okay po. So, ayan nga, example ng isang digital barometer. So, by definition, ano nga ba ang digital barometer or ano siya? Digital, it's a pressure sensing instrument composed of integrated circuit or IC, which combine electronic and mechanical elements to sense pressure. The most common microelectromechanical pressure sensor are either capacitive or piezoresistive. Yun po. So next is the gauge pressure.
Hello. Next type of pressure po is gauge pressure, also known as overpressure. It is the pressure of a system above atmospheric pressure. Gauge pressure is zero referenced against ambient air or atmospheric pressure. So gauge pressure readings including the pressure from the weight of the atmosphere. Yun po. Yung gauge pressure po is, ito po, mag-base po tayo sa diagram. Makikita po natin dito, yung gauge pressure po is, ano po, nasa taas po siya ng atmospheric pressure, which means po na ang reference po niya kapag sinusukat po natin yung gauge pressure is yung atmospheric pressure po. Unlike po dito sa absolute pressure na sa absolute zero po magsisimula yung readings. Ano po? Ano po yun? Ano po? Pakituloy.
Ano po sir, kung in unit po is
Apo. Zero po, sir. Zero po. Apo. Meron po kaming inihanda po dito. Yung sa absolute po is, ano po, yung atmospheric pressure po plus gauge pressure para po makuha yung absolute pressure. Opo.
Yes po.
Opo. Opo. Next. Ito po. Ito po yung ginagamit na pang measure sa gauge pressure po, which is boredom gauge po ang tawag. Dalawa po. Ayun. Tatlo po pala. Opo. Tatlo po, tatlo. Yung KPA po, bar KPA, PSI. Opo. Ito po, KPA po. Bar po, PSI. Apat, apat po pala. Opo. Opo. Mas per, zero po. Opo. 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 Negative 40. Vacuum pressure po. Ito pong red na indicator, yung kilopascal po. Opo. Opo. Ito po yung nasa kanan po, ito po yung makikita mo sa loob ng ano po, ng Verdon pressure gauge. Verdon tube po. Yan. Ito po, kaya po yung Verdon tube po na yan, nag-expand po yan or parang nag basta po nag-expand kapag ka yung pressure po is pumasok po dito sa socket. Ano po. Tapos, ito po nakikita natin na tip. Nakalink po siya dito po sa may segment level. Nagko-contract po. Kapag ka, nagko-contract. Opo. yung indicator po. Ito po. Nakalink po siya dito po. Kaya po kapag kuwari po nag-expand po is tataas po yung indicator sa pressure po. Tapos kapag nag-contract po is bababa po. Ganun po. Oval po, oval. Opo. Opo, C po. C po. Galing po dito sa indicator. Yun na po. Okay na po yan. Yun po yung pinaka-explanation po. Ito po.
Opo, may
Para
video
po,
po kami para po dun sa about nga po dun kay Ward.
opo, para po maintindihan ng mas malinaw. Ito po yung
Are used for the pressure measurement of relative pressure from 0.6 bar to
meron po.
1,000 bars. They are classified as mechanical pressure measuring instruments and thus operate without any electric power. This video will cover the following. 1. Working principle of burden tube pressure gauge. 2. Construction. 3. Working. 4. Advantages and disadvantages. If you are new to ADTW, click on the subscribe button below and turn on the notification to get all the updates from our channel. Working principle of burden tube pressure gauge. When an elastic transducer, such as burden tube in this case, is subjected to a pressure, it deflects. This deflection is proportional to the applied pressure when calibrated. Construction. A C-type burden tube consists of a long, thin-walled cylinder of non-circular cross-section, which is sealed at one end. This tube is made from materials such as phosphor bronze, steel, and beryllium copper, and attached by a light mechanism which operates the pointer. The other end of the tube is fixed and is open for the application of the pressure, which is to be measured. The tube is soldered or welded to a socket at the base, through which the fluid, whose pressure is to be measured, enters the C-type burden tube. Working of burden tube pressure gauge. As the fluid under pressure enters the burden tube, it tries to change the cross-section of the tube from oval to circular, and this tends to straighten out the tube. The tip of the burden tube is connected to a segmental liver through an adjustable link. The segmental liver end on the segment side is provided with a rack, which meshes to a suitable pinion mounted on a spindle. The segmental liver is suitably pivoted, and the spindle holds the pointer. The resulting movement of the free end of the tube causes the pointer to move over the scale. In real-life application, the pressure gauges are mounted with siphon tube. Siphon tube is a simple device used to protect a pressure sensor from high-temperature media, such as steam. It can also be used to reduce the potentially damaging effects of rapid pressure changes. When first installed, the siphon should be filled with water or some other suitable separating medium. This medium continuously remains in contact with the burden tube. Burden tubes are generally made in three shapes: C-type, helical type, and spiral type. Advantages of burden tube pressure gauges. 1. These burden tube pressure gauges give accurate results. 2. The cost of burden tube pressure gauges is low. 3. Burden tube are simple in construction. 4. They can be modified to give electrical outputs. 5. They are safe even for high pressure measurement. 6. Accuracy is high, especially at high pressures. Disadvantages of burden tube pressure gauges. 1. They respond slowly to changes in pressure. 2. They are subjected to hysteresis. 3. They are sensitive to shocks and vibrations. 4. Amplification is a must, as the displacement of the free end of the burden tube is low. 5. It cannot be used for precision measurement. If you want more in-depth videos like this, then subscribe this channel and click on the bell icon to get notified for every special video we upload. Also, if you have any doubt or opinion, comment it below, and help us by sharing this video with your friends.
So, Next.
Next po, ito po, nag-provide po kami ng parang simple na example po para dito po sa reading ng pressure po. Next, pakilagay nga po yung ano. Ito po. Ito po. KPA po. Ito po. Ito po. Sa gauge pressure po. Ito po. Makikita po natin yung indicator is nasa gitna po siya nung 4,000 kilopascal and 8,000 kilopascal. Since by 4 po yung ano po, yung parang measure po dito, nasa gitna po nila is 6,000 po. 6,000 kilopascal po or 6 MPa. Alin po sa po ulit? 870 PSIG po. Apo. Apo. 870 po. Apo. Apo. Ayun po nakalagay na po. Ito po, ito po. Ito po yung formula para makuha po yung absolute. ATM po. Eh, yung 1 ATM po is equivalent po siya sa 0.101325 megapascal po. I-add po yung sa, sa 6 megapascal para po makuha natin yung absolute pressure which is 6.1013. Ito po, sa PSIA po, mag-add din po tayo ng 1 ATM po, which is kapag ka-convert po natin yung 1 ATM, 14.7 PSI po, plus 7, plus ATM po, 14.7 PSI. Atmospheric, atmospheric po. Opo, opo, atmospheric po. PSI. Ano po? Yan, sagot.
So,
Opo, balik
next
po.
po.
Opo, next po.
So, next po is yung vacuum pressure po na tinatawag natin. Vacuum pressure is a negative pressure less than atmospheric or barometric pressure na. Nasabi na nga rin po kanina na ano nga, sa gauge pressure, nag-start yung readings sa ano na, sa atmospheric pressure. So, kinaibahan lang ni vacuum kay gauge is yun nga, negative siya. Ang yung how to put it, yung from the atmospheric pressure, papunta po siya sa absolute zero kasi nga vacuum. Then, ito rin, same lang din nung kanina ng measure instrument. Ano na po, below po sa ah, atmospheric pressure po. Apa, apa. Yan, apa. Dun. Apa. Complete vacuum. Apa. Ah, tas eto po, ang explain ko lang po is yung kanina, sabi dun sa video rin, saka sabi rin ng aking ka-groupmate, na etong Bourdon tube, kapag naka-experience siya ng gauge pressure or ng pressure na positive, is it tends to straight. So, ito is ang ano niya, let's say the motion is paganto, patayo. So, by mechanism, yan, nakalink siya dito sa the sector, or we can say a crank with gears. Then, ito, dahil pataas to, ito ngayon ay nakapin dito. Sa part na to. So, ito, yung motion na to is coupled. So, magkakaroon ng motion dito na pababa naman yung magiging rotation nitong sector na to. Pa counterclockwise. If gauge ang pinag-uusapan. So, ngayon, itong pinion, magro-rotate nga siya ng clockwise. So, na-valid naman natin na kapag ito nga, pag nagpe-pressure tayo nagme-measure tayo ng positive pressure, is itong pointer is clockwise ang niya, rotation. Yan. Then, how about naman kapag vacuum? Kapag vacuum, kabaliktaran naman. Si vacuum, so, etong si Bourdon tube, imbis na mag-tends to straight, it tends to to shrink. Paano shrink? Yung motion nitong tip na to, or nung Bourdon tube na ito, is pababa naman yung magiging motion niya. So, pababa siya, nakalink siya dito. Kung kanina, itong si sector, dahil nga nakalink siya dyan, tapos may pin dito. Kung kanina, ang ikot niya is pa-counterclockwise, ngayon, ang magiging movement na niya, since kailangang mag-couple dito, is pa ganon, or pa-counter, or pa-clockwise na. Then, may experience naman na rotation ngayon ni pinion is pa-counterclockwise. Then, maano na rin natin na, kagaya nga sabi kanina, kapag ang mini-measure natin is vacuum, itong pointer, it tends to rotate counterclockwise, papunta dito sa mga negative values. Ito pa. It could be it could be oil po, as na rin, as oil lang po. Okay po, glycol.